Hello! Great to see that you're back to learn more about the Robotic Enterprise Framework. So far, we've learned about the role of the initialization state, the exception handling mechanism, the InitAllSettings workflow, and the configuration file. In this video, we'll see how the REFramework handles consecutive system exceptions, as well as two other workflows that are invoked in this state: KillAllProcesses and InitAllApplications. Let's resume from where we last stopped. We've successfully read the settings from the config file in the InitAllSettings workflow and passed the data back to Main.xaml to the config dictionary variable. Remember that one of the key parameters in the settings sheet is the OrchestratorQueueName and OrchestratorQueueFolder. In the next step, the framework offers the option to overwrite the queue name by using a process configuration or runtime argument. A process configuration or runtime argument is an argument with the direction in declared in the project entry point, in our case, Main.xaml. But in main, from where would an input argument get its value? Values can be assigned from Orchestrator. To see this, we've already published this process, so let's access it from Orchestrator. Now all we need to do is go to the Processes section, select our process, click Edit, and provide values for the runtime arguments from here. Note that for attended processes, we can also assign values to runtime arguments from UiPath Assistant. In this case, we're not planning to overwrite the queue name. In the same way as the queue name, the OrchestratorQueueFolder can also be changed during runtime. It's important to note the following. If you have defined the Orchestrator folder, then your queue will be located there. A process uses the same queue no matter where it's published. The next step is to invoke the KillAllProcesses workflow file. This workflow is meant to force close all applications used in the process. We do this to make sure that the robot starts in a clean and controlled environment. For example, in our case, when the process starts, an instance of UI demo may already be open in an incorrect state, or maybe it's frozen. This would likely cause an exception. The placement of KillAllProcesses here addresses this plausible issue. By default, the workflow is empty, but we added the logic to force close the application we're using, in our case, UI demo. Following that, we add a custom log field with the name of our process as defined in the config file. This way, all of the logs created further will have the name of the process. This can help us to create reports and visualizations. We'll cover the details and benefits of logging in depth in an upcoming video. Following this, the framework checks if the maximum number of consecutive system exceptions has been reached. As a result, it checks for the following conditions. It first checks whether max consecutive system exceptions value defined in the config file is greater than 0. Following that, it checks whether the consecutive system exceptions global variable is greater than max consecutive system exceptions. If max consecutive system exceptions is 0 in the config file, then any number of consecutive system exceptions is allowed. If the condition is true, i.e. the max consecutive system exceptions value is greater than 0, and the consecutive system exception global variable value is greater than max consecutive system exception, then we throw an exception. This leads to the end process state, thus finalizing the process. The execution proceeds if the condition is false, i.e. there are fewer consecutive system exceptions than max consecutive system exception, or the value defined for max consecutive system exception is 0. Are you wondering from where and how the global variable consecutive system exceptions value gets updated? How does it know if it's a consecutive system exception? When a system exception occurs during the processing of a transaction item in the process state, the consecutive system exceptions variable value increases by 1. This value is provided by the in-out consecutive system exceptions argument in the set transaction status workflow. If any successful transaction occurs in between before reaching the maximum consecutive system exceptions, the value of consecutive system exceptions variable will be reset in the set transaction status workflow. This logic will be explained in greater detail in an upcoming video on the process state. Next, the InitAllApplications.xaml workflow is used to initialize any applications operated during the execution of the process. Note that the config dictionary object is passed to it via the inConfig argument. By default, the workflow is empty. We recommend placing the steps to open and log into applications in separate workflows, one per application, invoked inside InitAllApplications. In our case, we invoked another workflow, UIDemo-open, where we implemented activities to open and authenticate to the UIDemo application. That's all we need to know for the moment about the initialization state. After having watched the previous videos, do you think that you could answer a few questions about the initialization state? What are the key functions of this state? What transitions does it contain, and what triggers them? What workflows are invoked here, and what do they do? Now we're ready to dive into the Get Transaction Data state. Stay tuned to learn about it in the next video. Thank you for watching.